recording this. Or you can come in person and take the in-person one, and the in-person one is 24 questions. Okay, the online one, it is more difficult to test in math online. Okay, so it's longer. I don't remember how long it is. I have to look. It's longer, and it involves making a video explaining, I believe, 2 problems. Or just come in. And I will send out an email. I was going to say, and if you're in summer school during the day, but of course you're not in summer school during the day because you are joining me here. So any burning questions before we get started? Also attendance. Okay. Your attendance is taken every day. Now I say have your work for the day done by 3. It's usually after 3, and it doesn't necessarily need to be 100%, but I need to see significant progress, more than half of the assignments of the day completed. And I recommend you work ahead and not behind. Okay, so if you're taking the test in person, it will be, you are just going to come in at a time that works for you. So either from 8 to 9:30, but once we start the review session, no one can be taking the test, or 10:30 to 2 o'clock. Okay, so 10:30 to 2 is the opening, which means you need to be done by 2. And it would be great if everyone was gone by 2. So, so I can leave. So that's honest. There will be people coming in at 12:15 because they're taking a class at their homeschool as well. So hopefully that answers that question. Any other burning questions? Are we good? Any other questions? Okay. If you are feeling anxious about math, I recommend you stick around after the review session, and we'll just leave the Zoom session open. Okay, so you can ask me questions as you're doing your work and as they come up. Yeah, so I'll leave it open if anyone wants to stick around and hang out and just for office hours. Any other questions? So tomorrow there will be an assignment for Thursday that says, when you have finished and completed the practice exam, send me an email and I will send you the answer key for it. So you're just going to send me a message. I have completed and submitted my practice exam, and would you please send me the answer key? And that's how that works. Yeah. Anything else coming up? Okay, let's get started. And remember, it is in your best interest to, as I ask questions, type the answers into the chat. Even if you are not correct, type them into the chat, because it engages your brain in a kinesthetic way. Okay, find the measure of each angle. So, Zoomers, we know that no matter what the shape of the triangle, the 3 angles, the sum of the 3 angles of a triangle is equal to, yeah, Zoomers, someone type it in. Everyone type it in. Ding, ding, ding. Correct. Okay, thank you. 180. Okay, so let's put an X here. X plus 130 plus 25. The sum of the three angles of a triangle is always equal to 180. What's my next step for solving this equations? What do we call it? What math phrase do I call this? Combine like terms. Yeah, I call it CLT, combine like terms. So we have X plus 155 is equal to 180. And now we are in the isolate the variable stage. Okay, so what am I going to do to both sides now? All right, thank you. We're going to subtract 155. This one this side, it's 155. So thank you. Good job. Zoomers, how much is X equal to? 25. Thank you. Okay. So you are going to do number 2 on your own. If you don't want to do it on your own, you're going to stick around at the end of the Zoom session and you can request it. Okay, let's go on to number 3. Okay, classify each triangle by angles and sides. So if we look at the angles, it can have all angles less than 90 degrees. If all of its angles are less than 90 degrees, let's say all. If all angles are less than 90 degrees, then we give it a name, okay? Just the name that corresponds to angles. Does anyone know the name? Here's a hint. It kind of sounds like, ding, 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 correct. It kind of sounds like sneezing. Acute. Okay, some people sneeze like that. Or if they're less than 180, if they're less than 90, then they are like a little kitten or a little puppy. They are acute. So then we say acute. Okay, what if it has one angle greater than 90? Then it is classified as what according to the angles? Ding, ding, ding. Thank you. Obtuse. And what if it has one 90-degree angle? Yeah, if it has a 90-degree angle, ding, 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 we classify it as a right triangle. Okay, hopefully those words are familiar and you have been using them for several years now. Okay, now let's classify them according to their sides. If it has 3 congruent sides, 3 congruent sides, 3 equal sides, or if you happen to know Spanish, the Spanish word for sides is lados. So it has 3 equal lados, which helps us to remember that if it has 3 congruent sides, then we call it, anyone remember? Ding, ding, ding. Thank you. Equilateral. Okay. And why does it sound like equalados? Because English and Spanish are all Latin based. So you see a lot of prefixes and suffixes are similar, and root and whatever you call the thing in the middle. Sorry, not an English person. But anyway, base. No, I'd have to ask the English teacher. Anyway, you're going to see a similarity. Okay, so 3 equal sides, 3. Oh, hey, let's talk about this. Why does my equal sign have a little squiggly on top? That's not equal. Okay, if my equal sign has a little squiggly on top, that is what? Congruent. Ding, ding, ding. Good job. Congruent. So when do you use congruent and when do you use equal? Let's just write this down. Let's just take this in notes. Numbers are equal. Objects are congruent. Okay, so I say the sides are congruent. The angles are congruent. If I say the measure of the angle is 58 and the measure of the other one is 58, their measures are equal. Okay, numbers are equal, objects are congruent. So that's confusing. We can talk more about that later. Okay, 3 congruent sides. Okay, what if 2 of the sides are congruent? If 3 sides are congruent, it's equilateral. If 2 sides are congruent, there's no nice ding, 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 nice job. There's no nice Latin base for this. It is isosceles. Okay, 3 sides, equilateral, 2 sides, isosceles. Kind of sounds like sausages, like 2 sausages are walking and those 2 sausages are legs and they're congruent to each other. That may not have been helpful, but anyway. Okay, here's the hard one that everyone seems to forget. 0 congruent sides. 0. Now, I remember this one, ding, 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 nice job, because my first name is Carlene, which you don't know that. You just know I'm Mrs. Watts. Anyway, it sounds like Carlene. Okay, it is, ding, 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 good job, scalene. 3, 0 congruent sides. All 3 sides are different from each other. So okay, we're going to give it 2 words, one that goes with the angles and one that goes with the sides. Okay, so how do I classify this one? We're going to say angles first and then sides. No, sorry. Yeah, angles first and then sides. So everyone give it a guess. Okay, think ahead of me. You will do better if you're always thinking faster than your math teacher. Yeah, we've got a guess going in. Don't peek at the chat. Everyone type in a guess, please. Okay, we have a couple guesses. Now, I see one right angle. So there exists one right angle. So we say right. And I see no congruent sides. Yeah, 0 congruent sides. So it is right. Scalene. Okay. Okay, number 4. We're going to say according to the angles and then according to the sides. Okay, make a guess, please. Number 4. Ding, ding, ding. Obtuse, right? Because there exists an obtuse angle. And, oh, you know what? It's not scalene. Yeah, it's not scalene. It has 2 equal sides. It is obtuse isosceles. Okay, now, do you realize how good that is for your brain to participate, to guess ahead of me, even if you're not correct. Okay, it just engages your brain more fully. So good job, guessers. Okay. That's right. Okay, now this one, we're only going to give it one word. So either, oh, question? Oh, no. Oh, either we are going to say the sides or the angles, and only one of them is correct. Okay. Ding, ding, ding. Equalados, equilateral. Yeah, equilateral. Because if the three sides are the same, then the three angles have to be the same. And if the three angles are the same, then they have to be 180 divided by 60. They have to be acute. So equilateral will always be acute equilateral. Now, if you're taking the at-home test and there's a drop-down box and you have to choose something, you would choose acute. But most commonly, we're just going to say equilateral because it has equal sides. And every equilateral will have 60-degree angles. All right, number 6. Okay, Zoomers, type in a guess. Okay, we have 2 guesses. We have in existence 1 obtuse angle. Therefore, we only need 1. You can't have more than 1 because it has to add up to 180. Obtuse scaling. Yeah, obtuse scaling, using 2 words to describe everything but the equilateral. Okay, so 7 and 8, you are going to finish those on your own. Okay, on your own, or stick around at the end and we will do them. Okay, sketch and label, mark the figure, isosceles triangle, TRN. RT is equal to RN. That's actually talking about, okay, so let's talk about this. RT, if it has the little line segment above it, that is a segment. RT, if it does not have a little line above it, that is just the measure. Okay, and sometimes when I'm typing these in, I don't have the capability to put the little line above it. So the measure, hello. The measure of RT is equal to the measure of RN. Now, I cannot have you guys type this into the chat. Okay, so here is an isosceles acute triangle. Notice we're going to put a mark there and a mark there. Those, they're not equal until you mark them as equal. Okay, and we know the measure of RT is equal to the measure of RN. So Zoomers, type in please, what letter has to go on top? Ding, 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 R. Yeah, because that's the one. So RT, the measure of RT is equal to the measure of RN. Did not just happen. Or we could also say segment RT is congruent to segment RN. Yeah, an isosceles acute triangle where RT is congruent. Sorry, the measure of RT is equal to the measure of RN. Okay, now this is complete. I was going to bring something else up, but we're good. I don't want to complicate the issue. Okay, number 10. Sketch, label, and mark the figure isosceles right triangle. Measure of angle RAM is equal to 90. Okay, isosceles right triangle. It's going to look like this. So, well, it's isosceles. How about like that? That looks better. Okay. Isosceles right triangle. You with me? It's still not really isosceles looking, but I've marked it. So we're not going by how it looks. We go by the markings. Okay. Now, the big question is, I have to put the letters on. Okay. Everyone think, Zoomers, what letter needs to go on the 90-degree angle? Can everyone guess? All right, I have one guess. Yeah, Zoomers. I have two guesses. Zoomers, are you there? It's so good for your brain to participate. Okay, now. Okay, so RAM. This one, RAM. Yeah, the R and the M can actually switch, but the A has to be the 90-degree angle. It has to be at A. So there we go. Yeah, an isosceles right triangle, measure of angle RAM is 90 degrees. Okay, sketch, label, and mark the figure. A scalene triangle with angle bisector ray SY. So we're going to draw a scalene triangle. Okay, Zoomers, scalene triangle has how many equal sides? Ding, ding, ding. Thank you. Okay, now the angle bisector is going to be SY. So it doesn't matter where I put the letters. I'm going to do this. SCL. Okay, scalene triangle, 0 equal sides. And now, ladies and gentlemen, I want an angle bisector ray SY. Okay, so where are we going to put Y? Can anyone tell me if I want angle bisector SY, where I'm going to put the Y? You could just say on the left, on the right, or on the bottom. Otherwise, it's going to be difficult to explain. So angle bisector SY. I need to bisect an angle. Anyone have a guess? Can everyone guess, left, right, or bottom? Oh, we have two guesses. Any other Zoomers want to guess? The answer is bottom, because this says right here that the end point, oh, thank you. I got one more guess. The end point of the ray has to be at S. So I'm going to, now look, did that just bisect the angle? No, an angle bisector has to go in the middle. Okay, and I need to mark the figure that, oh, and let's put a Y. Okay, so I'm going to mark the figure that is the angle bisector. Now, if that is the angle bisector, this angle is congruent to that angle. Okay, now we have an angle bisector. Yeah, so that is how you show that you have an angle bisector. Mark the angles. It cut it into 2 equal angles with little tick marks. Okay. Sketch, label, and mark the figure. Isosceles acute triangle with base WX and vertex angle Y. Isosceles acute. Yeah. So mark it. If it's isosceles, you got to mark it. A vertex angle. Where is the vertex angle? Can anyone tell me? In one word, where the vertex angle is going to be in this triangle? It is up here on top. Okay, there we go. Thank you. The vertex angle is the one that touches both congruent sides. Okay, and the base of the isosceles triangle, WX, is across from, so the base is across from the vertex angle. Okay, so we're kind of practicing this geometry vocabulary. Now, we use familiar words like top and bottom, but we're learning to use vertex angle and base. Okay, the base WX is across from the vertex angle. Number 13. Locate point L so that triangle LRY is an isosceles triangle. There's actually an infinite number of answers. Anyone have, excuse me, anyone have a guess? Let's try 1, 2. Okay, so we have a bold. Oh, we have a couple bold people. So let's try this. 1, 2. So let's see. 1, 2, 3. 1, 2. Oops. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. Ding, ding, ding. Correct. Now, do we see how that is correct? Because it's in the middle. Now, can you see how that is correct? This one's correct. This one is correct. Any of those points on the middle, okay, so we also got a guess of 1, 0. Yeah, any of those points on the segment bisector would make an isosceles triangle. Yeah, do we see that? Nod your head if you see that. Oh, sorry, your cameras are off. Just kidding. Okay, does that make sense? You could also go here. All of these are examples of possible equilateral isosceles triangles. Okay, so one example could be 1, 2. Another example could be 1, 0. Now, does anyone see another isosceles triangle that they want to share? Sharing time. Anyone see a tricky one that does not have a point in the middle of the base? Let's see. 1, 2, 3, 4, 5, 6. This is 6. Okay, now you only have to give one. But could we do this? 1, 2, 3, 4, 5, 6. Except I went off my graph. Yeah, would that be an isosceles triangle? So there's actually a lot of correct answers. Okay. Or, you ready? I'm going to erase this. We could go here. 1, 2, 3, 4, 5, 6. Yeah, a lot of correct answers. Or are there two more that I could do that are similar to these? We could do it on the right. 1, 2, 3, 4, 5, 6. Yeah, I missed, but you get the point. Yeah, so 4, 9, or 1, 2, 3, 4, 5, 6. Correct. 4, -3. All right, thank you. So they could be in the middle, or they could be on the right or the left. So you should be able to, if I could make this multiple choice, and I could say, would this complete an isosceles triangle? Okay, that's enough of that one. Now, notice this one's different. Isosceles right triangle. And let's keep it on the graph. There's now only 2 correct answers. There would be one more, but it would be really, really tricky, and you'd have to prove that that was a right angle. So anyway, there's 2 correct answers that would stay on the graph. And let's just measure this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The measure of ME is 10. Okay, can anyone tell me? I want an isosceles right triangle. What could that be? Okay, let's try it. 1, 2, 3, 4, 5, 6, -4. Correct. Yeah, because that's going to be 10. So there is an isosceles right triangle. Okay, there's one more that could be an isosceles right triangle. How about 6, +6? Yeah, that's 10. And that could be an isosceles right triangle. Okay, so there are multiple correct answers. There are also a lot of incorrect answers, but there are multiple correct answers. Okay, now you notice you all are headed to Algebra 2 in the fall. So we're going to keep your Algebra 1 skills sharp. Okay, so number 15 on your own. 16 on your own. Let's do 17. Let's draw a line down the equal sign. So step 1, clean it up, combine like terms. Okay, combine like terms, please. Notice this is an equation, not an expression. So we're going to combine like terms. Okay, there's nothing to do on the left. -8b. Oh, sorry. There is something to do on the left. Yikes. Okay, what do we have on the left? Thank you. -13b. Okay, let's combine the variables. -12b. And now let's do the constant terms. -8. Yeah, everyone agree? I kind of like to put my variable terms and then my constant terms. It's just good practice. Okay, so we're isolating the variable. Someone is going to have to move because I cannot have variables on both sides of the equation. Now, some of you want to make sure your variable is always positive, and some of you, it doesn't matter. You want to do the fewest number of steps. So what would I move if I wanted to do the fewest number of steps? Who's on the wrong side? Okay, so correct. Let's add 12b to both sides. Yeah, so let's say that the negative 12b is on the wrong side. So negative 13 plus 12 is negative 1. B is equal to negative 8. And very often in solving equations, the last step is to divide. B is equal to positive 8. Okay. So if you are not confident solving equations, then stick around. We will do 15, 16, and 18. Okay, bonus content. Yeah, that's it, right? So we have bonus content. Okay, that may show up in quizzes that you do. Okay, bonus content. So what is this? That is not what it was supposed to be. Now what is this? You actually see this in like mom Facebook posts. Yeah, what is the correct answer? Everyone's like, I hate math. Okay, let's talk about the order of operations. This may show up in a Canvas quiz. Yeah. So we multiply and divide. Why are multiply and divide in the same line? Is multiply more powerful than divide? Or is there something else going on here? What are your thoughts on simplifying this expression? Left to right, ding, 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 or whatever comes first. Okay, so if multiply and divide, they are the same power. We are going to go left to right. So 12 divided by 2 is 6 times 3 equals 18. Instinctively, we just want to do multiply before divide. Okay, so keep that in mind. If you have multiply and divide in the same expression, right? This is not an equation, this is an expression. We're going to go left to right. Okay. Now you are going to see what is the LCD? Oh no, I want this to be a 6. Okay, sorry. This is what I want. If I ask, what is the LCD in a Canvas quiz? Because we are refreshing our pre-algebra and algebra skills. Then you're going to go 6, 8, 10, 12. Sorry. Okay. Did I mention I didn't sleep last night? Okay. 6, 12, 18, 24, 30, 8, 16, 24, 32. What is the least common denominator of 5/6 and 7/8? 24. Ding, ding, ding. So the least common denominator is 24. This might show up. Thank you. Good job. This might show up in today's working with equations, or maybe it was the attendance quiz. I don't remember. Might possibly show up. Okay. Now, what if it looks like this? And you are supposed to type what goes into A and what goes into B. Okay, so it has to be in a Canvas quiz. This is really hard for me to do online. So A equals B equals. Does anyone have a guess? Okay, so let's go ahead and do this. 3/5 plus 11/16. My least. Okay, let's do a friendlier one. Sorry. How about we do 15ths? Okay. 3/5 plus 11/15. What is my least common denominator going to be? 15. All right. So this one doesn't change. So what do I need to multiply by the top and the bottom to change it? Okay. The least common denominator is 15. Yeah. What am I going to type in? 3. So I type 3 into A and 3 into B. Yeah, that's what you type in if this shows up in a Canvas quiz. So I have 9/15 is, oh, look at that, 20/15 reduces, divide by 5 for thirds, reduced improper fraction. We're not really going to go to mixed number. Okay, so you will see occasionally some pre-algebra coming through. Okay, next. This is called creating and undoing, or complicating equations. Okay, complicating equations. I call it complicating equations. Some other teachers call it creating and undoing. So start with the equation x equals 7. Now work ahead of me. Multiply both sides by 5, please. So now I have 5x is equal to 35. Okay. Add 3. So can I just add 3 to one side? No. Whatever I do to the left, I must do to the right. Complicating equations or creating and undoing equations. Okay, last step. Divide by 2, and what do you get? There would be 2 correct answers here. 5x plus 3 over 2 is equal to 38 divided by 2 is 19. You can also say 5x over 2 plus 3 over 2 equals 19. You can either divide the whole thing or you can split and divide them separately. So creating and undoing or complicating equations. It is very important that you are good at solving equations when you get to algebra 2, advanced algebra next year. Okay. And it's great. Isn't this great? You guys don't have to spend 4.5 hours with me every day. But unfortunately, some people want to photo math or chat GPT it, right? So I really need you to be good at solving equations. You can't just go to advanced algebra and be like, oh, I don't know, I photo mathed. Okay. We want you to know how to create and undo or complicate these equations. And that is all. Okay, that is all for today, unless you want to request one of the ones I skipped. If I skipped it, then you are responsible to do it on your own, unless you want to stay and we'll do it together. Okay, some of you are going to be disappearing. So thank you for joining me. Does anyone have any question or request? Okay, bye-bye. Have a good day. Anyone staying and have a request? Now, if you came late and you missed it in about half an hour, thank you, you too. In about half an hour, the video will be ready and I can send you the link to the video. Burning questions. You're like, I love that you stay because you're thinking, I don't have a question, but I want to see if anyone else has a question. Any questions? Okay, signing off. I will see you tomorrow at 9:30. Same bat channel, same bat time. Signing off.